Hello, everyone. Thanks for joining today's session on building responsible AI agents on Databricks. We really appreciate it. It's probably the last talk of today, so thank you for coming and joining the session. I'm Pavitra Rao. I'm a delivery solution architect at Databricks.
Hi, everyone. Thanks again for joining. I hope that you are enjoying your summit. And yeah, I'm super excited to be presenting this topic with my colleague. My name is Yassine. I am a senior resident solution architect at Databricks, and I'm currently based in Singapore. So I just want to begin this talk by discussing a truth that many enterprises are grappling with. When AI systems make financial decisions that cannot be explained, for example, in loan approvals, credit scoring, claims, it does not just create opacity, but it also creates risks. Risk of regulatory non-compliance, risk of reputational damage, and also risk of perpetuating bias at scale and without even noticing it. So here's the opportunity. Responsible AI is not just a compliance checkbox. It should be an architectural choice, a choice that makes your AI systems not only defensible, but only reliable. So by building responsible AI agents from the ground up, agents that can be defendable, can be auditable, and also can be responding to your legal requirements or regulatory requirements, we will shift from this notion of being reactive through reactive damage control to proactive governance. So in today's session, we will show you how we can do all of this on Databricks at scale. The agenda for today is we will start by discussing the key challenges that enterprises are facing when building AI systems. And then we will talk about the key pillars of the responsible AI framework. Next, we will show you how Databricks Intelligence Platform and Mosaic AI toolkits can help us follow this responsible AI framework and build all of these guidelines and recommendations. After that, we will discuss our financial use case, which is credit scoring or credit decisioning, and we will show you the architecture design for our compound AI system before moving to a demo to walk you through how to build all of this on Databricks. So what stands in the way of building AI systems for enterprise customers? Let's unpack the 5 key challenges that these enterprise customers are facing today. We can start with bias amplification. So AI systems, they don't just reflect bias. They also can amplify this bias. When data is skewed and proxy variables or proxies creep in, the system reinforces all the inequities that we have in our data. And this is especially dangerous in financial use cases, for instance, in our credit decisioning use case. The next challenge is system fragility. So most customers that I worked with, or many AI systems that we built, they perform very well in testing, but they will fail or they will break in real-life scenarios. So we can think of model drift, edge cases, and also adversarial inputs. Without guardrails and deep stress testing of these AI systems, all the system will fail silently and predictably. Next, we have the lack of transparency. If I cannot explain the decision made by my model, I will not be able to defend it and validate it with the stakeholders. And this is not just a technical issue. It's also a business and a regulatory liability for most customers and most organizations. So without documentation, traceability, lineage, with time, we will lose the trust in our AI system. Then we have data privacy and security risks. We can talk about inference attacks, overexposure of sensitive fields, or even model training on confidential data. These all can lead to major compliance issues and problems for these organizations. And responsible AI starts with secure and privacy-aware data practices. The last challenge that we can talk about is governance challenges. So the question here is, who is accountable for what? Without clear ownership, audit trails, and coordinated deployment processes, responsible AI becomes an afterthought instead of being a built-in foundation in our architecture. So to address all these challenges that we just discussed, we need to build a framework. We need to think of a framework, not just ad hoc fixes along our use case or along our deployment of this use case. And a responsible AI framework offers the structure to build safe, trustworthy, and ethical systems by design. So for this framework, what we will do is we will focus on 5 key pillars, starting with fairness and inclusiveness. And this is, for me, arguably the most urgent pillar. First aspects can be bias detection and monitoring. Here we need to build in fairness metrics like demographic parity, equal opportunity, or disparate impact analysis. And we need to monitor all of these KPIs along the way, end-to-end in our compound AI systems. Explainable model decisions. So if users, as I mentioned earlier, do not understand why a decision has been made by a model or by an AI system, they cannot contest it and they cannot validate it, and also the regulators will not be able to validate it and approve it. So we can use tools like SHAP or LIME in order to surface the model decision and explain in detail why certain decisions have been made. Diverse data sourcing. This point is very important as well because bias often starts at the source of our AI systems, right? And with underrepresented populations or proxies baked into our features, we will have this bias reflected throughout the whole system. So actively audit and augment data sets using, for example, Databricks Marketplace to ensure representativeness across race, gender, age, and all of the sensitive dimensions in your AI system. And now moving to the next pillar, once fairness is addressed, the question that we ask now, can we trust the model to perform consistently in all environments? So enhanced AI effectiveness will help us make sure that the model is solving the right problem with well-defined objective and well-defined KPIs, and being able to monitor all these KPIs and objectives throughout our engagement. Consistent model reliability. So as I mentioned, the models should be able to generalize across different environments, data drifts, and also edge cases. So we need to make sure to implement robust evaluation pipelines like cross-validation, stress testing, adversarial examples, and also make sure to simulate edge cases very early in the process. Robust AI safety measures by leveraging safeguards like outlier detection, confidence threshold, and fallback strategies, or things that we discussed in the keynote or other sessions like kill switches, circuit breaks, where we have human in the loop processes. Next is transparency. So once we build systems that are fair and reliable, the next question is, can we understand how they work? So we need to have model explained properly and go beyond accuracy and ask why the model made certain decisions, right? And here, again, as I mentioned, we can use tools like SHAP or LIME in order to explain the full decision and have full traceability of how the agents are communicating or interacting with each other. And then we have unified governance and data lineage. This is where we will benefit from Unity Catalog and Unity Catalog lineage to have full traceability of how the data flows through the system, from ingestion all the way to deployment or all the way to inference. So the idea here is that with great model power comes great responsibility, right? Especially when it involves user and customer data. And this pillar is about protecting customer data and preserving institutional trust through the whole process and through privacy and security. So we have data privacy controls. This is the idea here is to use only the data that we need and make sure to leverage things like data masking, encryption, row-level masking, column-level filtering with Unity Catalog to make sure that we are not using any sensitive data in our AI systems. And I also highly encourage you to benefit from or to read through the Databricks AI Security Framework that helps you identify the different risks that we discussed and discovered with customers, and it gives you recommendations to tackle each of these risks. So the last pillar is accountability. And for this last pillar, it's most often the most overlooked pillar, because when the most ethical, private, and robust system means little, it will mean little if no one is clearly responsible for what it does, right? The idea here is that every decision, every data set, and model version should be traceable. And also, we should have like audit trails, documentation, and things like model cards, data versioning, to make sure we understand the whole flow of data and decisions. And the last one that I want to discuss for this framework is how we know who is responsible for what, right? So we need to assign owners, we need to define escalation paths, we need to automate reporting, and ensure regular reviews of the model behavior over time. Now, accountability, I consider it as the glue that binds all the other pillars together. It ensures when things go wrong in any of the other pillar, someone knows it, someone owns it, and there is a process to fix any issue that has been identified. That's how we make responsible AI not just a principle, but a practice that we need to follow when building each AI system.
Awesome. Now that we have understood what we need to achieve, let's talk about how to implement this RAI pillars in real system. Building responsible AI isn't just a one-step trick. Right? We need to have end-to-end support across the AI lifecycle, and Databricks Data Intelligence Platform, along with Mosaic AI, actually provides exactly what we need, and it is having built-in design for that. It offers an unified platform where all the components like data, models, evaluation, deployment, and monitoring, all of this come together. The AI developers can use LLM models, data retrievals, and even traditional ML models, and all of these components can be put together in a single compound AI workflow. And this is very crucial for our RAI framework. I refer to RAI just for ease, it's Responsible AI Framework, because instead of relying on one opaque, isolated models for the implementing RAI, here we can compose multiple components with clear responsibilities. So let's start with the build phase of our responsible AI agents, right? The first step is always about preparing the foundation. With no surprises, it's Unity Catalog where we ingest and catalog data, ensuring every data, whether it is structured, unstructured, this is all stored there for traceability and governance. Then we define tools, right? Tools are callable discrete functions, just like your credit decision model or like a simple SQL function, SHAP explainer, etc. These are your tools, and agents orchestrate these tools, and all the agents' tools and the data is stored in Unity Catalog for lineage and fine-grained access control with some of the features that Yashin was discussing. There are use cases where you would need unstructured data to be indexed into vector search, and this can also be stored in Unity Catalog or in Delta table and served through our vector search index. So your agents can extract relevant data, the necessary data that it needs to make the responses more usable, I would say, right? Context aware. We can build further the AI agents using the AI playground. We will quickly see all of this in the demo, but the AI playground lets us simulate agent workflow in real time, and it comes with built-in LLM judges, which is so crucial. Even at the prototyping level, you're trying to assess the correctness, the safety, and the relevance of the responses. Unity Catalog features like column masking can help mask your sensitive data and make it accessible to the right audience. You can scope the access to it. And further, ML flow, right? That's the next biggest thing that we consider is so critical in the AI framework is ML flow, experiments, the tracking of experiments, the runs, model versions, artifacts, and parameters, providing that full lineage and reproducibility, which is so crucial for our AI framework. We further integrate SHAP and Lime. I'm not sure how many of you have heard some of these functions, but these are like local explanations which can run on the model predictions and help us understand and make every prediction explainable. Why exactly the model predicted that particular value is the explainability that we need, the transparency. And these explanations, it's not just for the technical teams to make decisions. It's also for the power users, which can be like downstreamed through component, like front-end components like AIBI dashboards or your own dashboarding tools we can leverage there. Once we have some of the prototyping done, let's understand how to evaluate, right? Like this is such a key cornerstone for our AI framework. We begin with creating synthetic evaluation datasets to simulate edge cases, or there are scenarios that are sensitive to fairness and other rare events. So this is all possible with Mosaic AI Agent Evaluation Framework. Some of the announcements came today. As well, we have built-in modules to help create this evaluation set, which is representing your use case. It's representable to your use case or the application you're building. Why do we do this, right? Like, why don't I just use my subject matter experts or wait until I get the real data? That's not practical, right? There's so limited access to your SMEs and they have other jobs to do, so it becomes more costly and tedious versus using this approach, you're also not introducing any bias, human bias to the evaluation set. And all of this can help us assess the agent performance across different conditions. And as we discussed, some of the dependencies will also reduce. Agent evaluation, Mosaic AI Agent Evaluation also has an user interface which provides a side-by-side view of all the metrics. So your subject matter experts can go in, or even you as an engineer can assess the metrics, latencies, costs, and outputs, which further facilitates in debugging the quality issues of your agentic framework, the framework, right, the agent itself. Further, we have seen a lot of customers use marketplace a lot, especially regulated industries, to bring in external data sources and use clean room, right? This is so critical in financial services or even regulated industries that you want to use the data, and these industries have data sensitivity flags always high, but you want to partner and improve the model robustness. So through clean room, this is achievable without ever exposing the raw data. So Databricks platform doesn't just help us build smarter agents, but as we see here, it helps us build more inclusive and informed ones through external data and making it very robust for our models to improve on external data sets. Now that we've explored the preparation of the data, the prototyping of agents and evaluation, let's talk a little bit about iterative improvement, right? Like, it's not like set and forget. You have to have that iteration over improving this. So ML flow tracers can be used for agent, like evaluating agent behavior. We'll quickly see this in the demo, all the traceability steps it goes through. And we can also have observability hooks embedded at every stage. Like if an output looks off from the actual values that you have default set, it will trace back and provide alerts and also give you that whole traceability, model versioning, and understand what tools were used through the system, the Unity catalog, the entire prototyping system that we developed. Further, the code that was used in developing each version of this prototype is also logged. So every call of the model and the data is retrievable and fully traceable, and you can also reproduce it. Why do we do all this? It finally enables us with efficient root cause analysis, and you can further fix the gaps or the outliers that you see there. So for example, let's imagine if a bias is detected in the outcome of a certain group, age group of your model, right? We are talking about credit decisioning models. We can check whether it is originating from your feature store or the model predictions or even prompts that you're using through the entire system, the lineage traceability that we have. So we believe that this closed loop debugging is what makes our AI systems sustainable at scale. Even after deployment, a continuous monitoring plays a very crucial role here. We have Lakehouse Monitoring for our generative AI applications. This also came out as a new announcement this week, where we have detections that we can do for data drifts, model drifts, and shifts in fairness metrics. It uses the LLM judges, built-in LLM judges, and custom metrics for offline evaluation and online monitoring. And yes, we can set automated alerts. If a fairness threshold is breached or the agent performance is going down, the system can always flag, and optionally also you can have the agents pause making decisions and go back to a default system. So your front-end applications are running as is. Finally, let's talk about going into production, right? Pre-production step is very, very crucial. We can test the agent end-to-end, integrating all the tools and models, like online feature stores, vector stores, or even Genie rooms that you would use in the agentic framework. And through the review app that comes with the agentic framework, domain experts can give real-time feedback to the systems. They can assess the model responses and flag it, and also give expected behavior through natural language. This human in the loop review is where RAI becomes real, and loan officers can approve, flag, or reject the decisions, and all of this can be stored and provided as a feedback to your agent. All the model serving endpoints that we have comes with built-in safety filters and RAI guardrails, which can be applied not just at the model level, but the whole orchestration level, so that your models are not interacting with certain types of content, like PII data, sensitive data. And the final note here is the AI red teaming. I don't know how many of you have heard this concept of AI red teaming. This is mostly like systematically attacking your own model and do some diverse test in one of for safety issues, like detecting safety issues early on. And this has been one of the proven methods, even internally with Databricks. Our engineering team does this very often.
All right, so let's see how we can actually implement all of this, all the concepts that we discussed on Responsible AI Framework. And I will quickly go through the design and architecture that we will be doing during our demo. And for this demo, we thought of the credit decisioning financial use case, and we are using a supervisor multi-agent architecture to implement this credit decisioning chatbot. So at the beginning, or the first agent is what we call the data retrieval agent. What it does, it will interact with Unity Catalog, with Delta Lake, with your feature store table in order to retrieve the applicant's data, some credit bureau data, and some financial data in this context. And then it will send all of this data to the next agent that we call the scoring agent. What this agent does, it will load a credit decisioning ML model that we already trained and stored in Unity Catalog and MLflow, and it will give it all the features, all the data that we prepared in the first agent in order to compute the credit score for this applicant. And once we do this, we move to the next agent, which is the explainability agent that will help us identify the key factors that made the agent give us that credit score, right? So it explains what are the key factors, but it also monitors the bias and fairness of this score or of this decision. And of course, the last one, or the last agent that we also want to focus on, is the response generation agent. Because we have the score, but we want to have a full explanation and detailed explanation of why did this, all these agents made this decision and gave this score or this final decision for this applicant.
Awesome. So this is the credit decisioning advisor chatbot. This is built on Databricks Apps. What this chatbot does is simply takes in our user query to provide explanation on whether this customer will default the loan payment, and not only that, provide an explanation as to like why exactly this decision was made. So let's dive right in here. Initially, it will go ahead and provide us some risk score saying, hey, there is a high probability that this customer would not pay the loan. But as a loan officer, just the risk score of 1 and a probability value doesn't help, right? It's not actionable or not even providing the right explanation as to why this is. So with our agentic framework that we built using RAI as a ground there, or the pillars, it goes ahead further and explains what are the top features that are driving this insight. For example, transaction activity patterns, employment stability, and then account balance management. By the way, this model was given around like 10 to 15 features, final features, and based on the SHAP values, it is saying these are the 5 values that it thinks is impacting the score of 1. It also further gives us a more comprehensive business implications and what the loan officer should consider as a next step to do here in terms of the decisions and actions, right? And these things are something we can also provide in one of our agents, or like through the prompts. Prompts are really powerful, and we saw today the announcement. You can also track the performance of a prompt, how well your prompt is doing through our prompt registry. So overall, you will see that with the fairness note, so it's biased, it's guarded against biases. And one thing, if you're noticing the results here, we never display any sensitive information like age, the balance, or any other tenure. So we are making sure the output is also protected with not showing the sensitive data, but actionable enough for the loan officer to take next actions. Let's switch the gear and understand how this was built on Databricks. We start with Unity Catalog. Unity Catalog is where all your data, the models, functions, raw data sets, everything is stored. And not to like really miss this, it provides the complete lineage to understand the traceability. So if a prediction is made, we can understand which model was used, what model version, what code version. All of this can be tracked upstream and downstream. And the traceability is also built in to this. Once we have all these assets kind of stored here, governed, permissions granted, we can switch quickly to our prototyping environment, which is the AI playground. In the AI playground, we start with using our simple LLM models. Recently, Cloud Sonnet has been the best in reasoning, so we have ended up using the same for our demo as well. And the tools is where it's a game changing, right? You can start adding tools and other agents here, vector search, and then use prompts to start prototyping your agent. And one thing I want to highlight is the evaluation. Like we discussed, it's a cornerstone for our framework. So we will see here AI judges giving overall correctness of the response for your agent. So you start doing this at the prototype level, and it's not an afterthought. So once we have this built, we can quickly automatically generate an agent code. So you don't have to be an expert in LangGraph or Llama Index, some of these frameworks. You can quickly build this end-to-end code. And this comes with major steps like evaluation, which we discussed through the evaluation data set. And then you can register the model to Unity Catalog, deploy the agent to our model serving endpoint. But just to focus a little bit on the MLflow experiment, this is where we can implement most of our responsible AI framework and the pillars, the concepts we discussed. So when I go into this experimentation run, you can see that every experiment is being logged for us, and all the model versions are being logged here, and the code, and you can also trace it back to Unity Catalog, and that kind of closes the loop for us. And then further to look at the traces, right? We discussed this in the slides as well. For every prompt or every question that we send, we have complete detail about how exactly the agent went about giving the response that we have and the assessments. Now, if I'm a subject matter expert and an ML engineer, I can just start using this framework UI to say, hey, add a new assessment or other metrics. Makes it very, very easy and simple for traceability and lineage and audit, right? So we have this whole overall correctness, groundedness, relevance for this. And we can set up monitoring and tell, hey, I want to add more guidelines or like use the default judges. And coming back to the evaluations as well, we have every data set logged. And I won't go further into the details, but this is where our ML Flow 3 comes into picture, saying, hey, there is a feedback loop. For every new responses that comes, your subject matter experts can go through the UI, the review app. Most of you would have seen the review app, agent review app, and it's all tied back with the feedback model. And you can further use this for a next iteration of agent performance, right? Improve the performance with real-time data. Finally, let's say I don't want to use a chatbot versus me being a loan officer. I want to understand a customer portfolio. How is all these factors going to imply on my set of customers? What are the business opportunities? What are the risk profiles? I can always publish this into a dashboard. And this is an interactive dashboard where I can ask questions in real time. Through natural language, and I can start getting insights right out of my dashboard with AI and BI Genie feature here. So just to conclude this in the next 2 to 3 minutes here, we always want to talk about like what are the best practices, right? Like how do we consolidate everything we shared into an operational implementation? So without having to say, always ground the LLM in your data, ground the LLM in data, and explanations from LLM should reflect the actual model decision and the SHAP contributions that we saw, the factors that were implying or impacting the loan decision. Apply domain constraints and policy prompts, right? For example, if you are building an AI agent for loan communication, we have to make sure the domain constraints or the regulatory templates, so it knows the language and also phrases the denials according to the regulatory templates that we provide. Next thing is guardrails are mandatory. This goes beyond simple filtering, right? They include behavioral constraints and even routing logic. So guardrails are inevitable, just like human in the loop is non-negotiable, right? We saw how critical it is to have some of the reviews being reviewed by your loan officers, so your agent is learning from it and picking up the right behavior. And the loan officers are not just like overriding the AI. I think this is key to understand. They co-pilot with it, which brings a next level of transparency and confidence in the system. And this is not set and forget. It requires continuous monitoring, ML flow traces, agent evaluation, Lakehouse monitoring for Genie applications. We need to track every decision and improve them. Without tracking, you can't improve. Without measuring, you can't improve. So it's very, very important. And last but not the least, auditing for data lineage access logs should be built into the foundation. So every interaction, every output, every override is logged and traceable for further review as well. So just to conclude this, what we have shown today is that responsible AI doesn't have to be an afterthought. With the Databricks platform and Mosaic AI, we have a unified platform that builds trust into the AI development lifecycle.
All right, so I think just in the interest of time, we'll finish with this. For all the AI systems that you are working on, and after all the features that you've seen today, the concept that you should keep in mind is build once, govern always, and scale responsibly by following the guidelines that we discussed today or the framework that's published by Databricks. And of course, take some time to complete the survey and share your feedback. Thanks everyone for your time. I know it's a packed content, so feel free to reach out to us on LinkedIn or ask any questions if you catch us outside. Thank you, everyone.
Thank you, everyone.